Hello everyone and welcome to week 19 of the 20 and 20 challenge. Today we're going to be taking a look at Docker, and more specifically we're going to be taking a very introductory level look. So as opposed to going through a complete example where we set up multiple containers and use some of the more advanced techniques like Docker Compose, we're going to be using a single Docker file and we're going to be using an existing application. And I'm going to spend more time building up your base level knowledge of what Docker is, how it operates, as opposed to going into a specific use case. And then once we have those basic details worked out, then we're going to build out a small application using a single Docker file, and I think it's week 15's project, which I'll have a link to the GitHub repo and stuff like that. And then we'll just run a very small Rails API out of a Docker container, and we'll communicate with a Vue front-end app with this Docker container. That way you can get a high-level understanding of how it works without getting into the nitty-gritty details. And hopefully I can talk about some things that other people haven't mentioned, so you can walk away feeling like you understand the fundamentals of Docker better than if I had just gone into a very specific example. So hopefully this will help, and let's go ahead and let's jump into some code. Okay, so the first thing I want to talk about is the different ways that we can run a Docker container. So on a Windows system, you actually have two different options. You have the Docker GUI, which I have over here, which you can download from Docker Hub, or I guess hub.docker.com. And this lets you run your images and containers straight from the GUI. Now, a image is basically, you can think of it as like the image of the entire machine. So if you were to go out and buy a new Dell laptop, it might come with Windows, but it might also come with, Candy Crush or whatever, because they always put the bloatware on there. And all of that extra stuff is all packaged into the image itself. So in this case, I have a backend image, and this is a Alpine Linux image that also has Ruby with it. And if you wanted to, you could also customize it a bit more. And then once you have your image, you can then run your containers off of it. And these containers are going to be essentially clones of the image. So you'll have a base image, you'll run clones off of them. You might modify each clone a little bit if you want to. But mostly it's going to be like the difference between you and your friend both buying the same laptop, right? One person might go install RuneScape, one person might go install Minecraft, but ultimately you guys are still using the same systems. So in this application, you can both run your images and you can also run your containers that way. So the other option you have, if you're on Linux specifically, is you have Docker commands, and you can install this with, apt-get Docker, or you can do yum installer, APK, or whatever. But it's essentially the same thing, except you do it all through the command line. And because I have the GUI installed here, and I have the Windows subsystem for Linux, WSL, running on the system, I can actually run the Linux containers on my Windows system. And if I come down to the bottom here and click the arrow, you'll see that one of the icons I have here is Docker Desktop. And if I right-click on this, I can actually switch between Windows and Linux containers. So right now I'm on Linux containers, but if I were to go over to Windows containers, I could then spin up a Docker computer almost that would be a Windows operating system. Now, why you'd want to do that, maybe you have a specific Windows use case, your company uses Windows or whatever, but then you have to put stuff behind IIS and do all of that other weird configuration with Active Directory. And just in general, it's not a fun time, at least from my perspective. So I usually work with Linux containers. So I have the GUI just to see like what's going on without having to type some of the commands. But I do most of my work still out of the terminal. Now, the other thing you have, in addition to images and containers, is you also have volumes. And when you create these containers, they're not persistent. So the whole point is you spin up a container, you do whatever you need to, and then once you're done with the container, it just kind of goes away. And all of the data that was on it, that's gone now because you're really using it as like a smaller service. You're not trying to keep that data and keep that container in the state it was in. And for that, what you can do, let's say you spin up a container, like you have your Rails app, and then you also spin up another container. In that container, you put your database in. Maybe you want to create 5 different containers that all have your database. So you can have like 2 or 3 copies. And then you can have like, 3 different databases that the users can connect to with some kind of load balancer in front of it. And, it's not important how the load balancer works. It's one of those things where instead of pointing to specific databases, your users like GUI or whatever you're using for the front end makes a call to the back end, and it just says, I need to talk to the database. So I'm going to go talk to the load balancer, and the load balancer will say, well, this one's not doing anything. Let's go over here instead. And then that data gets replicated. So you have like a more performant system that can handle more users. And you also have that redundancy in case one database blows up, you have a backup. And in that case, you might run into situations where if you have like a smaller deployment that all needs to happen under one, gateway, you want to have like a specific IP address range. So let's say you have 16 IP addresses because you're expecting to have 16 systems. And you want all of these Docker containers to sort of run under those so that when you try to communicate with the Docker containers, you can ping 192.168.0.3 or 0.12 or something. And it's just easier to use. And in that case, what you can do is if I type Docker network, you actually have an entire Docker network manager that you can use. So you can create your own networks. You can assign subnets. You can run your Docker networks under bridged or NAT adapters and all of that stuff. So there is a lot of additional capabilities here in addition to like what is generally covered on YouTube. Because generally YouTube will either cover, what an image is, what a container is. It'll cover like Docker Compose, which is just a file you make to spin up a couple containers, or it'll just go into Kubernetes and clustering and all of that, which is mostly used for larger enterprise applications where you're going to have more than a few containers you're spinning up. So if you have like a smaller workload, you might use Docker Compose. And then when you get to the larger applications where you're like, oh, we're going to need like 100 databases for this thing, that's where you'd move over to Kubernetes. But a lot of times it's kind of glossed over that Docker does have some of this other functionality for the networking and, the volumes and all of that. And people just sort of gloss over what it actually does and how it's actually used. So today what the plan is, I have this Vue application from a previous week. I think it was week 15. And this was just it's a Rails backend. So we have a Rails application here. And then we also have a Vue 3 project as the front end. And what we're going to do is we're going to take the backend application, so the API, we're going to put this inside of a Docker container. And then we're going to have a front end that just sits on like our computer, and our computer is going to communicate with the Docker container. And that's really the whole use case we're going through. And, if you're going into a production environment, you wouldn't have the container on your own computer. You'd probably put it up on like your server or something. But it's a good first step, and hopefully it'll get you a bit more familiar with how Docker works. The other part of it is, sometimes the hard part when you're dealing with a customer is the setup of the environment, because you're sort of guaranteeing to the customer that your application will work. But if you have like some domain specific setup or the dependencies, like maybe you're unintentionally using something, it requires Python 3 and a specific version of the C++ compiler and all that other stuff. And like the C++ compiler might be, a gigabyte in size. A lot of that setup can really take up a lot of time, and you might install the wrong version, and then suddenly the application stops working for the customer. And the customer comes to you and they're like, man, what's going on? I paid for this application. Where's my functionality? And you have to say, well, it's not your fault, but it's kind of your fault because the system's not set up right. And when you ship a Docker image, you can just say, here's the entire environment with the application on it. Run the start command and move on with your life. So that's also a portion of it. So hopefully by taking an application like this and just packaging up a subset of it that might be a bit more difficult to set up, you can sort of see where the value is of shipping things inside of containers or images. But okay, so we'll start off. you're going to want to clone the 20 and 20 project, and you're going to want to grab week 15, and then we'll just grab the, I guess, the video folder. Now, if I remember correctly, we are going to need to make a modification to the back end to make this work. So the first thing I'm going to do, because I already have this on my machine, the actual source, so I'll just do a cp-r and I'll copy from ... or I guess I have to navigate up, I have to cd up, and I'll do a cp-r from ... week 15 video, and I'll just paste that into here. And hopefully I don't have the node modules in my front end folder from when I ran the video, and this should hopefully copy over fairly quickly. Okay, now I'm going to cd into the video folder, and then I'll just run a code dot to open this up in my Visual Studio Code. Now we can move this over, and I'll minimize all of this, and I'll collapse all of these so that we now have a clean slate. Okay, so the first thing I'd like to do is I'll open up the backend folder, and we'll come into app, controllers, API v1, and the to-dos controller. And one thing I noticed was we're just rendering this JSON out as @todos.reverse, and we actually need to do @todos.reverse.each. And that should hopefully fix up a bug with the data being not in the format that the front end's expecting. So once that's done, we can then, you could run the application if you'd like to, but I'm going to skip that step because for some reason I trust myself. It'll probably come back to haunt me later. The next thing I'd like to do is we'll right click, create a new file under app. Actually not under app, we'll create a new file under backend, and we'll just call this Docker file. Now really you can name this whatever you'd like to, but in this case we're just going to name it Docker file. And what this Docker file is when we're creating our image, so like our Dell machine, it's the operating system we want on it, and it's the bloatware that we want on it. So the initial thing that we're going to ship with our laptops, that's what that's what we're going to put in this file. And the nice thing about Docker is the syntax is really simple. It can be a pain to work with sometimes, but the actual syntax, you have commands like from, or run, or cmd, or if you want to, set your working directory, you can do, I don't know what it's trying to open right now, but we'll just ignore that. You can do like workdir, or if you want to copy something, it's just copy. And there's really not a lot of commands here because most of them you just do under run anyways. So, okay, we'll start with from. And for this, we want to grab and you can see here, tab 9 is already predicting what I'm going to type. We're going to grab the Ruby image, and we're going to say, I want Ruby 3.0.0, and I want Alpine. And this is just off of the Ruby Docker Hub. If you search for it, you should find that they have a whole bunch of different versions. Like here, you can see some of the auto completion already kicking in, but I'm just going to use 3.0.0, and I'll just use Alpine Linux. So this is an Alpine Linux image, and it's going to be running Ruby 3. So we already have all of that included. Now, the next thing we're going to do is we're going to do a run command, and we're going to add in some dependencies. And now for Alpine, instead of using yum or apt, you can use apk add. And we'll just do --update --virtual. And now what we're going to do is a series of dependencies that we want our image to have by default. I don't know why this got resized, but let me just resize this up a bit, and I'll drag it down here, maybe. Apparently my WSL is having a moment. So what we can do is we can enter down, we'll tab over, and then we'll say we need some runtime dependencies. We need build-base. We need libxml2-dev. We'll do libxslt-dev. We'll skip this one, and then we'll go over to Node.js. We'll do yarn, libffi-dev, get tz-data, and then finally we can append a and rm-rf, and we'll get rid of this temp data here, which is the cache apk /star. So if we were to run this right now, it would just add in all of these dependencies. So I'd like to add in a command where we can see Docker failing to run because we haven't set up our Docker file correctly. So what I'll do is I'll come over to my terminal. I'll restart it first, and then I'll come over. And then I will do a docker build dot. And then I guess I can do, actually I can do -- tag, and I'll name this the video backend. And then I'll do dot. So docker build -- tag, the name of the thing, and then where I'm building from. And right here, you can see that because I'm not inside the backend directory, there's no Docker file here. So if I type ll, there's no Docker file. So let me cd into backend. And then from here, I'll try running my docker build command again. And now this will go through. It'll do some things. In my case, all of this is already cached because I've already done this before. So all of these steps are skipped for me. The next one, I can hopefully get it to blow up on. And for this, I'm going to say we're going to need the SQLite gem. So I'll say run gem install SQLite 3-v will be 1.4.2. And then I'll grab this from source, rubygems.org. Then I'll save this, and then I'll run my docker build command again. And here you can see it didn't cache because it actually ran into an error. And the error it ran into is it didn't have the native build dependencies. And the nice thing about this is, if I need to do any sort of debugging here, and I need to set this up, normally when I'm recording a video, this is where I basically restart the entire system to make sure I have a default environment so that everyone can follow along. But if I'm using Docker, I just keep running the commands until I figure it out, and then I just list the commands in order. And this missing command here is actually, it's not SQLite, it's the SQLite build tools. And you can find that somewhere in here, and it ends up telling you need the SQLite development tools. And if you go to Google and you search around, you'll find the Alpine Linux repo that tells you the package this is in is the SQLite-dev. So we just copy this off their website. We come over to our Docker file, we paste it in, and we add a slash at the end of the line. And then we run our docker build command again. And because everything's cached for me, this probably took a bit longer for you, but for me, it just finishes up right away. So now let's keep going. The next thing I'm going to do is I'm going to set up a working directory where I'm going to be running the Rails application from. So I'll say work dir, and I'll make the directory named app. So on my machine, this would be like if I were to cd into /app. The next thing we can do is we can say, let's copy this backend directory. So we'll just say copy dot into this app directory that we just made. So it's copy from the directory on your PC, which in this case dot is just my current directory, into this directory on the Docker image. And then we can move on. We can then say env, let's set the bundle path to be /gems. And then let's say we want to run bundle install. And then we can run yarn install. And then we'll want to do a couple Rails specific things here where we want to first set an entry point. And we want to set it to be entry point with the square brackets and quotes. And we want this to be bin/Rails. If you're wondering what extension I'm using for all of this autocomplete, it is called tab9, I believe, which does have a paid version, but I think I'm on the free trial or something. I think it's tab9 autocomplete. But it is nice. It does save me some time while I'm working on things. And finally, after we have the entry point, we need to run a command and we need to expose a port. The command we're going to run is just going to be cmd, and then we have a list of comma separated values inside of quotes. And because we're running bin Rails, that's the same thing as me coming in here and saying Rails, and then I want to run a server, which would be Rails S, and then I would want to bind it to a specific IP address so I can talk to it. So I'm just going to take this. I already have the Rails, so the first argument is going to be S. Then I'm going to have -b, and then I'm going to have 0.0.0.0. And because I like using port 3000, I can then say, let's expose port 3000. And that'll work just fine. And then once this is done, we can come back to our terminal and run docker build. And this time, this command should take a lot longer unless you mess something up like I just did. But eventually, you should get to step 6, and it should yell at you about your Ruby version. And that's because our app is still set to use an old version of Ruby. So we come into our Ruby version. We'll change this to 3.0.0 to match our Docker file, and then we'll save this. Then we'll come to our gem file. We'll change this to 3.0.0. We'll save this. And then our gem file lock will yell at us for outdated gems. And we don't want to listen to that. So we'll just delete this and pretend it doesn't exist. And once we delete our gem file lock, we can then run our docker build command again. And hopefully, if I did things correctly, which is a stretch, following the gem bundling, we should have a working Docker image. Now, unfortunately, it doesn't cache the bundle step because things change. But aside from that, this should be fairly quick for successive runs, setting aside the bundle step. So I'll see you after this is done. Okay, and now we have our image created. So if I were to do Docker images, I think, you can see quite a few images that I have here. I have 2 that I must have spun up 25 hours ago, and I have 1 that I spun up 3 days ago. And if I come over to my actual Windows GUI, you can see that the Docker image we just created is right here. And if we come over to our containers and apps, this is still empty. So we now have a Docker image, but we don't have a Docker container, which is that thing that people always say you want. So to run a Docker container, we're basically going to do this docker run command and set this up so that we have a running instance of our image. And for this, I will never remember what the command is, but I believe what we can do is say docker run -p, and then we want to bind our host machine. So this computer's port 3000. So if I go to localhost port 3000 on this machine, like right here, I want this to go to my Docker containers port 3000. So when I run this Docker container and I try to communicate with it, my machine will assign port 3000 to this Docker container. So it'll know if it sees port 3000, it just says, okay, that means go to this Docker container. And then in here, I want to say inside the container, take port 3000 and send it from my host machine's port 3000 to the port 3000 in the Docker container. And I'm just doing this because the Rails server is going to run under port 3000 by default. If I were to change the Rails server inside of our Docker file, I would then have to change this port. But I'm not doing that. I'm just exposing port 3000. And once that's done, I think we then just have to name this maybe, or we have to tell it what image we're using. So if I come over to images, I believe we named it video-backend. So I'll say video-backend. And then if I hit tab, it'll actually auto-complete that for me. So this full command is now docker run -p 3000:3000. So our ports, and then the name of the image we're running. If I hit enter, there is a 20% chance this will work, and a 90% chance I've done this incorrectly. But it looks like it's started up, so that's a good sign. Let's go to our localhost port 3000. We'll run this, and we're getting an error here for no route matches favicon, but you can see we're actually talking to the Rails server. And I didn't start this up locally. I started this up in the actual Docker container. So if we remember from week 15, I think the route is /API/video or /v1/todos. So I'll go to that link. And you can see here there's some more to-dos listed in here because I already had a database created in the application. So if you don't have a database, I might ask you to run the migrations, or you can just run, bin/rails and do your DB migrate through a command, which I'll leave as an exercise to the viewer. But the basic idea is just you run your Rails DB:/migrate command inside of here using a run command. So now that we have this done, let's see if we can get the Vue project to work. So for this, I'm going to have to open up another Linux terminal. If you're wondering why I'm not using the Windows terminal, it's because the current Edge build of Windows that I'm on is actually so horrendously unoptimized that using the Windows terminal causes my 2080 Ti graphics card to completely crash. So that's just a fun insight into why you should test your code before you push it. But okay, let's go into /video, I think, and then we'll go into /frontend. And I'll do an npm install. That'll run. Okay, let me actually minimize this one because we don't need this one right now. I'll type Control L to clear that. Now I'll do an npm run serve to run my Vue application. It's like it's working. It's telling me to go to localhost port 8080. So I'll do that. Say localhost port 8080. And just like that, we have a Vue application. So let me try deleting some of these. That seems to be working. I'll say test. That's a new test one. I'll mark it as complete. And then I'll try to refresh. And it looks like that works as well, which is also fairly neat. So we now have a local version of a Vue application running here. And we have a backend project that is running outside of a Docker container. So this is basically the entire workflow, at least as far as creating your first image and creating your first container. Now, you might run into situations where you have a need for more than just one container. Like ideally here, it doesn't really make a lot of sense for me to take my entire backend and throw it into a Docker container. Because what would it look like if I scaled this? I'd just have multiple instances of this whole app here, which I guess that's okay. But then if I have like a user database with like login information, I'm going to have to send you to like specific websites so that you can log into your user account. And in that case, you might want to use something like Docker Compose to spin up multiple containers. And you might have one container that just runs your database, one container that just runs your app, and stuff like that. And for that, you'd want to look at a Docker Compose tutorial, which might be step 2 for you. And after you look at Docker Compose, maybe down the line you say, okay, well, I have a need for a larger workflow. And that's when you're going to want to start looking into Kubernetes. Now, you might come across some people that say, don't use Docker Compose, it's bad, it's not industry production ready. Or you might say, don't use Kubernetes, it's overkill. I just want you to remember that if one of these was objectively just bad, it probably wouldn't exist. So there is a time and a place to use one or the other. And I'd suggest looking into both and weighing the pros and cons and being realistic about what the scale of your application is that you're planning on building or that you currently have, and asking yourself, is Kubernetes excessive or is Docker Compose not enough for what I need? And then maybe you say, okay, well, for now, Docker Compose is fine. Down the line, though, Kubernetes would be better. And then you ask yourself, do I just go Kubernetes now, or do I wait until I go down the line and then I just do an upgrade then? But I think that's going to do it for this video portion of the tutorial. So now I'll go ahead and I'll cut to the outro. Okay, well, that's going to do it for this Docker tutorial. Hopefully this video helped you. Hopefully you left feeling as though you learned something. Maybe Docker's not as scary anymore. You have like a basic understanding, which will allow you to, build on your foundation of knowledge by watching some of the other great tutorials on YouTube. And then hopefully this can just serve as your foundation as you go forward in your Docker career. And maybe, who knows, this time next year, you'll be scaling through Docker swarms and all this stuff that I still don't fully understand. But hopefully this video helped. If it did, please remember to like it. If it didn't help, I guess you can dislike it, but YouTube might be taking that ability away soon, so I don't know if that's still going to be a button you can do. But, do what you need to. Hopefully this helped. I'll see you in the next video. Thank you so much for watching.